I found some really compromising things in the database, and so I went up to him at school and told him that if he didn't leave me alone, I would tell everybody about his secret crush and all kind of different things. So it did work, and you could think that, well, bullying a bully is kind of justice. I mean, would you have done the same? Who would have done the same? Yeah, okay. It's about half the room. So, remember, this was the 90s, so concepts of data privacy were not as prominent they are today, but I couldn't feel right about what I did. Something inherently was wrong. Just because I built a service didn't mean I had the right to invade someone's privacy, no matter what they did. And so privacy for me is something I've been thinking about since the 90s as a big problem we had to solve online. And it turns out that I wasn't the only one to do that. There was a group of people called the cypherpunks, which were basic cryptographers and privacy researchers that were thinking about different ways where you could use technology to protect digital privacy. And a lot of those people became very famous. So Julian Assange, for example, WikiLeaks was a cypherpunk. Phil Zimmermann, the inventor of end-to-end encryption, was a cypherpunk. And even Satoshi Nakamoto, the inventors of Bitcoin, was a cypherpunk. So all of those modern privacy ideas basically came from the same group of people in the 90s who thought that privacy was a big deal. And even though nobody knew it was a concept, it was still important to think about how to solve it. And importantly, the main tenet of their manifesto, called the Cypherpunk Manifesto, which you should really read, is that privacy requires encryption. The best way to guarantee privacy online is to encrypt everything all the time. This is why we went from having an internet where nothing was encrypted to what we have today, this HTTPS, this small lock in your browser, which signifies that the communication between your phone or your browser and the server is encrypted. So nobody can listen to what you're saying on the internet, but the company that's offering a service still has the data. So let's imagine, for example, that I'm using some kind of a photo filtering app. So I would take a picture, I would encrypt it on my phone, send it encrypted to the cloud. So the provider in the cloud would have to decrypt it because it has to do something with the picture, right? It would apply a filter on it, so a fisheye one in this case here, re-encrypt it, and send it back to me. So even though the data is encrypted when it's being transmitted, the company offering the service has full access to the data of every single user of their service. And so naturally, governments looked at that and they're like, oh, hey, why would we want to go after every individual user if there are companies that are basically collecting the data about everyone? Let's just go and ask those companies for the data. And we kind of knew this was happening, but we didn't realize the extent at which this was happening until the Snowden revelations in 2013, where we realized that big technology companies were directly giving access to the databases to the government. So this is as if me, as a teenager in my social network, were giving access to the French government to the messages of everyone. And so we're like, okay, so maybe protecting data when it's being transmitted is not enough, right? We need something else. And this was even more a problem because the number of records being hacked by hackers was exploding exponentially. So we had mass surveillance and we had massive hacking, which got us to a point where nothing we did online was basically safe. If you followed recently, there's a bunch of hospitals that got hacked and all the data is available on the darknet. So this is no longer anecdotal. This is a real huge problem we have today. So why is that happening? Well, it's happening because the data isn't protected and encrypted all the time. It's only encrypted when you transmit it. It's not encrypted when you process it. And so that creates hyper-concentration of data in a handful of big companies that are offering all those services we use every day. So what we really want is end-to-end encryption. We want to be able to keep the data encrypted during processing during transmission and during processing. And so for that, there is a revolutionary technology. I think you've guessed how it's called, homomorphic encryption. Maybe you didn't guess this one. So the idea of homomorphic encryption, of FHE for short, is that you can basically keep the data encrypted even while you're doing something with it. So to take again the example of the photo filtering app, so I would still take a picture, encrypt it, send it to the service provider, but this time they wouldn't need to decrypt it in order to apply a filter. So they would keep the data encrypted. They don't have the key to decrypt it. I kept it on my phone, but they can still run some algorithms on it, produce a result which itself is encrypted. So they have no idea what came in, but they also have no idea what they're responding back. Send it back to you and you can decrypt it. So in this particular instance, You as a user are accessing the same service. I'm sending a picture, getting a response. From my perspective as an end user, nothing changes. But from the perspective of the service provider, he no longer has access to the data itself. So if a government came and told the service provider, give me access to all of your users' data, what they would get is a whole bunch of encrypted pictures. Not much they can do about that, right? Homomorphic encryption is a technology that's even resistant to quantum computers. So this is a really big deal because it means that as a company, you can offer the same service you've been offering all the time without having to worry about data security, without having to worry about privacy, without having to worry about surveillance. And so what I'm convinced about is that there is going to be a point where every service we use, from smart contracts on blockchains to your voice assistants, to your healthcare providers, are going to be encrypted end-to-end. Because if you can, why wouldn't you? Is there a reason why you wouldn't want to do it? I can only think of two, actually. The first one is you're incompetent and you don't know that this is an important thing, so it happens, some people don't care. Or, you have some kind of business which requires selling the data, which I personally consider should not exist. So the point is, in the 90s, we didn't have any encryption at all. Nothing was encrypted. The data we were transmitting was accessible by everyone. The data that was processed was accessible by the companies. Thanks to Snowden and everyone else, everything now is encrypted in transit. So 90% of everything you do online is encrypted when you send it. And thanks to homomorphic encryption, I'm convinced we're going to have a new extended protocol for security, HTTPZ, that will enable end-to-end encryption in everything you do online. So you're never going to have to think about that, right? As a user, you're not going to have to care about privacy, not because it doesn't matter, but because it will be protected at the level of the internet protocol by the developers of applications themselves. And so that's why I think that people shouldn't care about privacy. That's not your job. Your job is not to think actively, oh my God, how can I protect my data? That's the job of developers building applications. They're the ones who can make that happen. Individual users should just use the services and go on about their lives. So why am I talking about this? I'm talking about this because this is the picture I was told was the future as a kid, right? This is a scene from The Fifth Element. A lot of technology is very heavy. There is policing everywhere, advertising, manipulating your every thought all the time. But who really wants to live in a future that looks like that? Anybody likes that? Yeah? So you think surveillance, you think advertising, nudging, and overwhelming technology is cool? I agree. The flying cars are cool. Yeah. Okay. So take that one, not that one, and then everything is cool. I agree. So no, the point is when you ask people what they really want, they want something that makes them feel safe, right? They want to feel relaxed. They want to feel, just happy in general. And when is the best moment you feel like that? Pretty much when you're on holiday. And so I know it's a big of a stretch, but I'm convinced that homomorphic encryption is the kind of technology that it can enable us to feel the same way in our everyday lives as we do when we're on a holiday in the most private and remote place. Thank you. Any questions? Yeah.
What are the technology barriers for that kind of encryption?
So there used to be three main problems. It was extremely difficult to use. Unless you had a PhD in cryptography, you couldn't really use this. We've solved that problem. You now have basically frameworks where you can write Python code, you can write traditional non-cryptographic code, and it would automatically convert it into something that can run on encrypted data. The second problem was you could do very simple things with it. You could add numbers, you could multiply numbers, but you couldn't do machine learning. You couldn't do complicated kind of like workflows. So that is also something we've solved. That's not a problem anymore. You can do anything you want, including deep learning. The last problem to solve is performance. Because you're manipulating encrypted data, there is roughly a factor 1,000 slowdown. So something, is taking 1,000 times more computing power or time to actually do. But this is something that's being solved at the moment, notably with specific hardware chips, so accelerators dedicated for homomorphic encryption. So within the next 2 years, there's a dozen companies which are currently working on accelerators. One of them is here, actually, that are pushing those products to the market. So homomorphic encryption by 2025 is a technology you can use cheaply, reliably in 80% of your applications in the cloud and on blockchains. So we still have a little bit of work. But we've solved the hard math problems, right? The technology is a done deal once we get those accelerators out in the market. Yeah?
Is this something that government would actually legislate for?
Governments would love to use that because it would give them the opportunity to use the cloud without having to trust the cloud providers with the security of the data. So if anything, governments is one of the early adopters of homomorphic encryption.
In terms of legislating that all services online do need to go online?
I think that this would be equivalent to requesting that everything is encrypted end-to-end. And so that's going to be the usual fight between freedom and privacy versus surveillance, right? So I gave a talk about that at a conference of all of like the top police and military people in France, right? So literally a room of people fighting crime in every kind of way. And half the room was for encryption because what they said is we have more to lose by having our data accessible to a foreign enemy than we have to gain from, like catching one more person, in France or whatever, right? But the other people said, yeah, but when we do catch someone, it's kind of nice to see everything they've been talking about with their friends because then we can catch their friends, which is true, right? And there is a real issue right now of surveillance, versus privacy that needs to be solved. I think mass surveillance has never shown any advantage. Like it's not as good as we're promised it is. Targeted surveillance is very good. And the good thing for targeted surveillance is that you don't need to see the content, you just need to see the social network. You need to know who's been communicating with whom. Homomorphic encryption doesn't hide the metadata, it hides the data. It's kind of like your messaging app. When you and I exchange a message on Signal, the telecom operator knows that I've sent a message to your phone number, so they know we talk to each other. They just don't see the content. And that's the only thing you need to target surveillance. If you're a terrorist and you're talking to someone often and you've spoken to someone 5 minutes before some kind of terror attack, most likely we should put that other person under surveillance.
Yeah. So it sounds like this is something that would definitely legislate for.
But they should. I think that goes in the line of the GDPR and all of those privacy regulations. They'll probably say something like, you can do it, but we need to have the keys, which doesn't work in this case because the service provider doesn't have the key. The whole point is that the key is with the user. So you need to go to every single individual requesting them to actually give you their keys. But that wouldn't work for foreign companies. So when you think about, for example, data sovereignty in Europe, nobody cares where the data is located anymore if the keys and the processing is done encrypted, right? Like I could send my data to be processed in China if it's cheaper than Europe. They still wouldn't be able to see the data, even though it's on Chinese servers. I'm not nothing against China. I'm just taking a random example. Yeah.
Those data hosts thrive on the data that they own, that they have. Is there a role for a new data provider that doesn't care about the data?
But that's the thing I'm challenging. I don't think people care about the data. I think they care about what they do with the data.
Well, yeah.
And you can still do whatever you want with the data. You just don't see it. That's a very big difference.
If they can't manipulate your...
You can. No, you can. Of course you can, right? Because homomorphic encryption, you can do whatever you want with it. You're just doing it blindly. So you can program a black box that does exactly what you want, but you cannot see the content of that box. And this is the important thing. So you can still do exactly the same thing, right? So you can do machine learning, you can train your models, you can do analytics, you can do targeted advertising. Everything would work. You just don't know what you're doing. I know it sounds a bit crazy, right? But that's the concept, and that's why it's so powerful. Is that when people say that data is valuable, they don't mean data is valuable. They mean what they're able to do with the data and extract from it is valuable, not the actual data. And this doesn't change that. That just removes the responsibility of securing the data in the first place, which I think is a benefit, right? Yeah.
So in that case, how do you deal with the need to deal with explainability and to combat things like bias in the data?
Yeah, no, that's a fair point, right? Whenever you have to do data exploration, for example, You need to have a human look at the data. So homomorphic encryption is not going to help a human, looking at data. If you have to look at data, you have to look at data. But it's going to help when everything is automated. So I think what's going to happen is we're going to use a lot more, for example, synthetic data. We're going to use a lot more of opt-in data the user gave us specifically for the purpose of research. They're still going to be visible, right? But as soon as everything is automated, you can make it encrypted end-to-end. So for example, for machine learning, the initial exploration maybe will be done on a small data set, but the full training that requires data from millions of people can be done encrypted. Yeah.
So I think really interesting talk, so thanks.
Thanks.
I guess when you think about, you sort of sold the utopia dream now all into, but then when you think about commercializing homomorphic encryption, what are some of the challenges you found in Zama with potentially getting customers?
Well, so the first challenge is that there is no market because nobody was expecting this technology to exist for another 10 years, right? So you have to create the market. And there are two ways you can go about that. You can verticalize in specific industry where the technology in its current state can work, or you can go bottom up and basically build a developer community and see what they come up with. So we've decided to focus on open source and developer community building. So everything we do is open source, and our goal is to get as many developers as possible to start experimenting with this technology as we get it fast enough to be commercially available. So this means that as a company, we specifically refuse to spend resources on niche verticals because what we care about is that this ends up being ubiquitous, right? And this will come from developers. We cannot build every solution, but we can build something every developer can use. Yeah.
Just on that, how much do you think incumbents with existing software can port? Because you mentioned the frameworks are helping with that. Do you think it's going to be something that they can actually port their existing projects?
Yeah, that's the whole point. So the way it works, technologically speaking, is we have Rust and Python front ends. So you can use that just like you use Python and Rust, right? So for example, the Python front end is plugged into NumPy and PyTorch. So if you're a machine learning data scientist, you can just write a PyTorch model or a NumPy program, and it will automatically get converted to FHE. And the way this works is you've got a kind of compiler, which takes this high-level language, turns that into a cryptographic program, figures out every single detail, the right parameters, the right performance, security kind of trade-offs, and produces an executable. So it's still the same thing. You're writing code, you're compiling it, and then you're running it. But the compilation process is not just about traditional compilation. It has this whole transformation into cryptographic code thing. And this is really where the game is right now. The game now is no longer about making it work. It's about making it easy and making it fast. And I think making it easy, I think we're pretty much there. Making it fast, Florent will make it happen.
I was going to ask you actually on that, what's your opinion on how this is going to affect the industry over time? Because when the crypto companies left their legacy, at consultant level, but also at startup level, people had to change the business side and angle because, of course, the end-to-end encryption for communication was no longer a problem. So now everybody altered their services.
Yeah.
So this is effectively going to have a similar effect.
Sure, of course.
So how do you think, for example, that's going to change?
I think it will start with industries which are early adopters of this. So that's why, for example, we're very, very bullish on blockchain adoption of homomorphic encryption. Why? Because it's a new industry where cryptography is deployed at massive scales, where people are very comfortable, using new cryptographic techniques, and where the problem is huge. Everything on a blockchain is public. So if you can make it encrypted, you can have blockchains where you have private, decentralized applications. So I think you need those kind of massive industries where this is solving an existing problem today to actually start using it. For traditional cloud, I think it's going to start with things like machine learning because I think privacy and machine learning is starting to be like a common thread. Your voice assistant. My previous company that got acquired a couple of years ago, we were doing a private by design voice assistant. Why? Because if you're going to put a microphone in your house, it kind of feels weird that people can listen to what you're talking about, right? So this is a perfect example of a technology that solves that problem. There is zero downside to using it. But yeah, I think you just need one or two big players to start using it for everybody to have to use it.
Maybe one day I'll buy Alexa if Amazon starts to use it.
So in fact, if you buy a Sonos speaker, our technology, or my previous company technology is in it. So you can use that. Yeah.
Are you working with any semiconductor companies right now to make
Yep.
it possible to bring about
Yep.
hardware acceleration?
Yeah. So that's one of the big things we're focusing on is working with the hardware companies to help them build those accelerators. It also helps us understand what we need to change on our side, in the compiler and everything to better suit those things. So there are multiple approaches. So Florent's company, Optalysis, for example, does it with photonics. There are companies doing it with traditional ASICs, companies trying to do it with FPGAs. So you've got a whole range of strategies which are being tested right now. Because we need this factor 1,000 to 10,000x acceleration to really cover 80% of use cases. But it's happening. So we are working with at least 7 companies which actually have a roadmap to deliver an accelerator in the next 2 years. There is a dozen more which are currently exploring whether or not they want to get into that, including some of the very big companies like Intel. So it's going to happen. Someone's going to crack it. Even the, I would say even the people who are working on zero-knowledge acceleration are now starting to bridge with homomorphic encryption because it's very similar primitives to accelerate. If you're a semiconductor company, we can talk about it. We've got a great training program. We spent a day together. We teach you everything about homomorphic encryption, and then you can build whatever you want on top.
I'm not, but I may have.
Great. Awesome. Yeah?
So the big companies, they need a software to be able to work with the encrypted files that they're receiving.
Yeah.
Is it
There is an SDK that does the encryption decryption. But if this SDK is directly in the browser or your smartphone, then it's just an API call. You don't have to worry about that. I think eventually that's what it's going to be, right? Or you can even think about it like a crypto wallet, your MetaMask. It could be used to have any kind of keys. And if you're not actually aware of that, there was a recent web standard that was ratified at the W3C around decentralized identities, which are basically cryptographic keys that you're going to be able to use to log in and sign to all kinds of different services. So the concept of holding and using cryptographic keys to access services, like we do in blockchain, is going to be super widespread in the next 3 to 5 years. So putting your FHE keys in it, is just another type of key. But I would say the user experience and adoption is not going to be the problem here. Okay, thank you very much, everyone.